Hi everybody, I'm Aaron from Sibling Rivalry, and today we're going to be doing a quick tutorial on how to modify a 3D design using Tinkercad to do this.
A machine that can make copies of almost anything.
Like I mentioned, we're going to be doing some tinkering, I guess you could say, with Tinkercad. So we found this great design on Thingiverse that allows you to adapt your Click and Grow 9 Smart Garden to use the lights as just a standard grow light. We're actually going to have a video on that in the future. One thing we noticed though when we printed out the design, it works perfectly with the Smart Garden 9, but with the Smart Garden 3, it is an earlier version of the Smart Garden, or the Click and Grow, and unfortunately this mast, or whatever you want to call it, these connector posts, are different. So it doesn't actually fit on there. Like, you could force it on there, but it'll just break. So we're going to show you how you can go from this design that's pre-made and go on Tinkercad and modify it to this. So like I said, today we are going to be printing and modifying some bases for the, like as you can see here, for the light section of the Click and Grow. So this allows us to reuse the Click and Grow for any plant, as you can see in this picture right here. I've already downloaded this design, and I've actually printed out two of them, as you've seen, and they work perfectly for the Click and Grow 9 parts. But if you're aware of this, there's the two versions of the Click and Grow, and we actually own both. I own the Click and Grow 3, Val owns the Click and Grow 9, or the Smart Garden 3 and the Smart Garden 9, depending on where you see the, depending on who you ask. That's the different names. So this is the longer section for the Smart Garden 9, and you can see that it has a certain kind of keying to it and a certain shape. This is a newer design. Originally, they started out with the Smart Garden 3, which has this design. Now, it wouldn't be too much of an issue too often, because the newer stuff is actually backwards compatible with the older stuff. The problem that I'm having is these feet are designed for the newer stuff, and that isn't backwards compatible that way. The pieces are actually wider, as you might be able to see here. Let's see if we can get that up nice and up close for you guys. Maybe that's too close. But yeah, the inner keying part here is too wide for this, and that results in these feet that we've 3D printed not fitting on the Smart Garden 3. So we could just kind of suck it up and be like, oh, I guess we just can't use the Smart Garden 3 for that, and we'll just make do. But no, I've got a 3D printer, I know some CAD, we've got the design file, or at least the STL file, so I'm going to modify it to make it work for this, and that is what we're going to do today. So I've already got it open up here in Tinkercad, and I just renamed it to Click and Grow 3 base, because I'm going to be making this a whole new version. In theory, it should be compatible with the Smart Garden 9, or Click and Grow 9, depending on which branding yours has. I haven't done anything to this yet, so before we get too far ahead here, I actually just want to move this design around to get a little bit better screen real estate. And as you can see, this pathway here is actually keyed, so to speak, and it has a bit of a chamfer to it. I don't know what to call that. It's angled. It's keyed almost like a dovetail, which it doesn't necessarily need to be. It's just he's mimicking the designer's mimicking the design of the actual Click and Grow, which has the same thing on it right there. So I'm going to widen that, because that was the first thing I noticed when I tried to plug the Smart Garden 3 into this. This is not wide enough. So how I'm going to do that is I'm actually just going to take a cube, a void cube, so to speak, and I'm going to line it up with the bottom there. You can see it's just starting to intersect with the base there. That's where we get that weird shadow effect. Okay, now I'm going to narrow this down. It doesn't really matter how much we're going to take off here. This isn't too important structurally when you look at it, but we do want to make sure that it is nice and aligned with that. So that's lined up in there. We're essentially just cutting out a new keyway in here, and maybe that is a bit too much actually. I think it should print fine. It shouldn't cause any issues. And if you look at, like, when you actually print this design out, this part right here is actually very thin, the way that it prints. It's actually almost, there's some weird geometry issues that happen there, and it ends up being pretty much translucent. So I'm just going to cut this whole thing out of here, and we should be perfectly fine. So I'm going to select both of them with the shift key. You can also just go here, and then actually you just drag over both. As long as they're both selected, then you just group together. And there we go. We've got a wider keyway. This should fit everything nicely. It'll be nice and loose. Now the other issue is the width of this. And yeah, I'm just going to take a sip of my tea here because I'm getting a little thirsty. Delicious. There's some nice orange pico with a bit of cream, 18%. Okay, so when we look at these two pieces, the width is the big issue that we have when it comes down to it, other than that little channel being too narrow. So we want to make sure that the width of this little prong bit here matches the width of this. So what I'm actually going to do, rather than measure that out and try and figure it out, I know it fits perfectly into this, like it fits like it's literally this. So what I'm going to do is I'm just going to measure this, because that's easier for me to do, and I have a pair of calipers right here. So got my digital calipers. These are ProSize brand. Realistically, most calipers that you spend less than like 50 bucks on are going to be the same. I think I spent like 15 or 20 bucks on these. They're pretty good. They're decent for their price. They work. I've got a little metric to ISO chart on the back. Yeah. So I am going to just check to see if this is proportional to this. So that's 33.9. I'm just measuring just the bottom of this, because this is tapered as well. So that's 33.9, and that is 40.05. So this actually is a different shape as well. The other one's more rounded. This one's a bit more cubic, if that makes sense. Here, I'm going to measure that again because I've just lost the numbers in my head. I should write this down. Okay, 33.9. Yeah. Okay, so it's 33.9. I'm just going to load up a calculator here. 33 point, it was almost 0.95. I think with the margin of error on this guy, I'm just going to do 33.95. Okay. And this is, I should do the wider one first. 40.05, so. Oh. Yeesh. 40.05 minus 33.95. Okay, so there's a difference of 6.1, so that tells us that the wall thickness here is about half of that, because that would be a diameter, and a radius would be half of that. So, and I can probably even just test this right here. It's going to be about 3 millimeters. Yep, 2.97. So, excuse me. Just make a mental note of that. I'm going to then measure this, 38.15. That's this guy, right? Yeah, that's the outer width. Equals, oh. No, I did that wrong. 38.15, right? Yeah, okay. And 31.99, so I'm just going to round that up to 32. Yep, it is pretty much 32. Minus 32. Okay. Yeah, so we got pretty much the same diameter. So these are proportional, which is what we were looking for there. It's just, we just have to scale the whole thing to match. So, we essentially have to decrease by whatever the difference is in the two mating parts. So, okay, let's clear this. Take the wider one. Oh, there we go. 33.92, right? That was, yeah, 33.95. 0.95 minus, let's measure that one again. I know I literally have these numbers in front of me. 32 minus 32. .95. Okay, so if I reduce it by 2 millimeters, we will have more than enough for it to still mate successfully with the other piece. So I'm going to reduce this by 2 millimeters on each axis. This is the easiest way for me to do this. I could probably do this all sorts of different ways, but so minus 2, that would be 133. Okay, there. That should match perfectly. Now something I'm going to do, or that I've been thinking about, is potentially trimming this down, because this takes a long time to print, and I'm not sure it really needs all of this extra material. I could probably just shave off, not the whole thing, but at least down to here. Let's zoom in, see what the height difference there is. So that looks to be about 0.5. Yep. Okay, now we just kind of move over. In case you're wondering how I'm moving, when I tilt like this, I'm holding down the right mouse button and moving the mouse. And then if I hold down the mouse wheel, it actually drags the view screen, so to speak. So, do this. Which those commands tend to be pretty standard for most CAD that you'll see out there. So it's a transferable bit of information, thankfully. Okay, now let's just extend this out this way. We don't need to make it the whole thing. I know it doesn't hurt to make it larger, but let's do that. Group them. And there we go. Much smaller. Okay. Let's just lower this down to 0. There we go. Could have just typed it in, but where's the fun in that? Okay, so yeah, looks good. Check that edge. Yep, it looks good to me. And I'm going to export this as an STL. Save. Okay, and now that that is saved, I'm just going to open up Prusa Slicer here. We're going to take a quick look and see what the print time is, because originally it was a 7-hour print. But if we can reduce that even by an hour or two, that is super handy for me, because my printer is busy like all the time. Yeah. Okay. So that reduced in size. Let's see what the print time is. Now I'm using Angus's profile from Maker's Muse, and you can just search for that and you'll find it. I'm doing this on the Sidewinder X1. I just renamed everything. I named my printer Bertha. I just name all my machines at this point. I've got a brim on there just to kind of help with adhesion. And yeah, it looks like it shaved off almost 2 hours. So I'd call that a success. Obviously, we'll have to see how well this prints and make sure that it didn't mess with anything. But the great thing about 3D printing, I can always go back and change the design and print a new one. Just got to work on getting myself a filament recycling thing. Alright, so that about covers it. We're going to print this off, and then we'll see you in the outro. Now that we've finished up the design and 3D printed it, we've got it all assembled here, and we're just going to plug it in here. We've got a crispy wave, and there you go. The cool thing about these Smart Garden lights is they have a timer built into them and a AC adapter built in. So you literally just plug it into a wall. It's on for 16 hours, off for 4. 8. Or 8. Apparently I can't do math. So yeah, stay tuned for a video that we're going to have up probably tomorrow regarding how to do some urban gardening and indoor gardening using these. So until next time, my name's Aaron. If you liked the video, please give us a thumbs up. We really appreciate that. If you have any comments on how I did this or different suggestions on how to do this better, feel free to leave us a comment down below. We'll get back to you ASAP. And if you like this sort of content and it's something you want to see more of, make sure to subscribe. We're going to have all sorts of different content over the next few weeks. As long as Val and I are both in quarantine, we're going to keep pumping out videos so that you guys get something new every day to watch. Hope you guys stay safe out there. Remember to wash your hands, use soap, 30-second rule, and have a good day. Bye for now.